everybody. So today we will be covering section 6.7. So we're going to learn how to solve radical equations. Okay. So on to the right, I gave you guys some steps for solving a radical equation, and we will do those starting with section 1, example. Okay. So the example given is 2x minus 7 plus 2 is equal to 5. Okay. So let's look at step 1. So step 1 says isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. So as you can see here, there's only one radical, which is the square root of 2x minus 7. So for step 1, all we're going to do is we're going to get this by itself. In order to do that, so it's this plus 2. So what we're going to do is we're going to subtract 2 from both sides. So that gives us the square root of 2x minus 7 is equal to 3. Okay. I want to emphasize, so the reason why I'm using arrows, an arrow is because I have an equal sign here, so we're going to use arrows instead of equal signs. Right, and this was step 1. Right, so what does step 2 tell us? Step 2, it says raise each side of the equation to a power equal to the index of the radical. So over here, what is the index? So when there is no number shown, our index is 2, right? So for step 2, what we're going to do is we're going to raise these to the power 2. So let's do it here. So 2x. Right, so we're just going to square both of these. Right, and then so we did that, and now for step 3, we want to solve the resulting equation. If the equation still has a radical, repeat steps 1 and 2. Right, so let's do step 3. So step 3, we're going to solve this. So the square root of 2x minus 7 quantity squared, that is just 2x minus 7. Why? So on the side over here, I will talk about it. So when you have the radical, so if we have the square root of x, what is that? That is x to the 1/2. So this becomes 2x minus 7 to the 1/2 squared. And so we can multiply, so if it's a power to a power, we can multiply. So 1/2 times 2 is 1. So this just becomes 2x minus 7. And that is how I get this. Right? And that is why we square, so that's why we raise it to a power equal to the index, is so we can get rid of the radical, right? And so now what is 3 squared? It's 9. And so we got to keep, so since the equation, so there's no more radicals under this equation, so what does that mean? We're just going to solve for x now. So then this is 2x. So we're going to add 7 to both sides, so then I get 2x equals 16. Then I'm left with x is equal to 8, right? So before we know that this is a solution, step 4 states that we have to check the potential solutions in the original equation. So why do we have to check our solution? So first of all, it's always good to check, right, to make sure that we did our work right. But another reason why is because of the square root. What is the restriction for even power roots? The restriction is that it has to be a real number. So it has to be a positive real number. So if there's a negative number under the square root, so say that we have negative a, then what does this tell us? This is not a real number. Right? So that's also why we have to check our potential solution. So I'm going to bring step 4 over here, right under this work. So step 4, I'm going to take this x equals 8, and I'm going to put it in the original equation, which is right up here. So this is 2 times 8 minus 7 plus 2. Is this equal to 5? Okay, so then we get, so let's solve it here. So 2 times 8 is 16. 16 minus 7 is 11. Give me 1 second. Okay, guys, I figured it out. I don't know how to do basic math, obviously. So 2 times 8 is 16. 16 minus 7, that is not 11. I do not know what I was thinking at all. So sorry about that. So 16 minus 7, that is 9. Right? So keep that. So is this equal to 5? So the square root of 9, that's 3, because 3 times 3 is 9. Right? And then as you can see, so 3 plus 2 is 5, and it definitely equals, which definitely equals 5. What does that tell us? That tells us that x equals 8 is our solution. Right. So before I end this section, I want to do one more example. So I'll call this example 2. I want to solve for the variable for negative 2 equals to the square root of 5x minus 24 minus 1. So before I start, so in step 1, why do we isolate the radical? So the reason why is because if I get this right away and I square everything, okay, then I'll get 4. And then we're going to have to FOIL this. And then if we do that, we get 5x minus 24. And then it's going to be what? Minus 2 square root of 5x minus 24 plus 1. Right? As you can see, this does not get rid of our radical. All right? It just gives us something even longer and just more complicated that we have to deal with. So that is why we have to isolate the radical first, because then we can for sure get rid of the radical. Right? So now let's talk about this example. So in this example, so step 1, we want to isolate the radical. So what am I going to do? I'm going to add 1 to both sides. So this is minus 1. So when I add 1, it's negative 2 plus 1, which is negative 1. This becomes 0, and then we're left with 5x minus 24. Right? So one thing that should actually be added to this step is if it is an nth root, or not an nth root. If this is an even root, what do we know about even roots? So let's say if I had like negative 4 squared, we know that is positive 16. If I have negative 2 to the 4th, that is positive 16. If I had even like negative 1 to the 100th, what is that? That is positive 1. If there is an even root, if it is an even root or like even an even power, so if it's an even power, you always end up with a positive number, right? And with an even root, what do we know about even roots? There can't be a negative under it. But that's another point. So since we know for a power, so when you take the square root of something, of an nth root, it's always, or the principal root of a positive root, it should always be positive, right? So over here, as we can see, this is negative. This can never happen. If you take the square root of a positive number, you're always going to get a positive number. And so since this is negative, what does this tell us? This tells us that this is no solution. Right? And that is the end of our section.